Hi, everyone. Thanks for coming today and welcome to this month's webinar. This time we're going to talk about automation. And this session started, it came to me like I was teaching like courses of automations over the last few months. And these were usually for the target audience of manual QA, manual testers. Don't like this term, but it is what it is. Who were trying to turn into the world of automation. And apart from the things that I taught in this course, I saw that there was a lot of missing background information for what is automation in general and not what is in the testing field. So this is my version of introduction to what automation really is, and it's going to be across the development spectrum. So yeah, I hope you enjoy it. I hope it's going to be valuable for you. If you're first time coming into this kind of webinar, so I'm Gil again. I live in Israel. I'm a trainer and I'm a consultant, and I also do webinars. And I talk about all kinds of things with all kinds of people who want to create better software, developers, testers, product people. I train and consult on clean code testing, automation, what we're going to discuss today, development, unit test, TDD, and everything in between. Like I said, the agile stuff. I'm the author of 2 books, Everyday Unit Testing and Everyday Spring Testing. And if you'll check out the chat window, there's going to be a link for a discount for Everyday Unit Testing. So if you really want to get this book, and you should, you can check it out on the chat window that we put it there. I want to mention that this information is part of a whole set of automation courses that I do. You can check them on the site on Everyday Unit Testing or testingguild.com. You can do automation in Postman, automation in Java, C#. I'm now working on a course in C# for both API and web automation. So I'm going to mention the topics I'm talking about today in these courses as well, but let's talk about robots. So I want to start with what we perceive automation to be. And automation is perceived to be like, we want to speed things up, especially in the testing context. We're doing a lot of things repeatedly. Some of these things are error prone, obviously want to speed things up. And usually this is why when people turn to automation, this is like the motive. But is that the real goal? Well, it is some of it, but I do want to focus on what we want to do. And that's not on a personal level, it is on the organizational level. At the organizational level, basically what we want to do is we want to achieve quality repeatedly, quickly. I kind of managed to squeeze those into 3 things. Quality. Quality is basically what is important for us. Like, we don't want bugs, we want the product to do what it needs to do, it needs to solve problems. Quality is value to someone, like Tom Gibson. But we decide what quality is. Repeatedly means that we want to do this over and over and over and over again. None of what we develop today is one shot. We always do these iterations. We do releases. It doesn't matter if you're doing like sprints or whatever sort of agile that you do, or waterfall completely, it's still going to be in releases. Nobody does like a one shot. So that means we're going to need to do these kind of releases repeatedly, and we want this quality to return. We want to keep that in an iterative manner. On top of that, we really want to make sure that our releases are like as short as possible. Because if we don't maintain this quality and repeats over and over, we're going to make longer releases. We're going to bog down under bugs. We want to always make a release as quickly as possible so we can get feedback, see how it's going, make sure that we're going the right way. If not, turn left, turn right, it doesn't matter. But the quicker we do this, we kind of improve our way of getting back to a product that makes sense to someone, the quality. So quality repeatedly, quickly, and I'm going to repeat that. And if this is what we're focused on, automation is just one of the things that help us do that. Basically, we have in our bag of tricks, processes, practices that help us do that. The processes are mainly the human ones. We do design reviews and we do planning meetings, and basically we have our own process, or everyone has their own process of doing things that make sure that we don't forget stuff. We communicate okay. We have less translation errors between development and testing, for example. So design reviews and code reviews and planning, test planning, these kind of processes are not tools, but they help us get to that goal. We have practices, more technical practices, like clean code and walking skeletons and spikes. Spikes, if you don't know what they are, it's basically building prototypes. What are we doing with prototypes? Before we don't know how to build something. So we do a time box, we build something, and we learn from that. So spikes is a technical practice that we can learn and improve on our way to our quality repeatedly, quickly. Walking skeletons, building something end to end, including maybe automation of it, from something very lean, like in a hello world program, and continuing to add layers to that and always have something working. It's a technical process or practice. And obviously automation becomes part of that. So we're going to talk about all kinds of automation, and not just the task automation, because there's all kinds of things that are automated around us and all over the world, our world, that help us get to there. So whatever Daleks you're running into, it's an automation. We do all kinds of automation. We do coding. We do all kinds of things in coding. I'm going to mention a few that are automated. Building the software, like we have compilers and we have transpilers and all kinds of things that bring packages from the internet without us going to the internet and getting it and copying files. Obviously, we do testing in automation. Deployment, we move software from one place to another in a package, in a whole thing, with the right versions, automatically, not bit by bit or file by file. We do a lot of shortcuts. Shortcuts is something like we run scripts in order to set up something in order to do the next thing. And I'll give an example about this. Reviewing. Reviewing means looking at some kind of results that we have and doing something with it. So quality gates could be like the decision maker, but look at the test report. If everything's not every test is passing, we can automate stuff that will look at the results and not everything is passing. Therefore, we're not going to do something else. Or every automated test is passing, then we can do something else. So reviewing and making decisions, not just by involving a human, and we can even deploy to production if everything is okay and we've decided that's our process. So we can automate a lot of stuff. But we always need to go back to this thing here, because if we're doing anything like a process or an automated practice or automated process or whatever, automatic or not, whatever you're doing in terms of process, if it doesn't get you there, if it doesn't optimize your way to quality repeatedly quickly, That means that it doesn't help. It doesn't help. Excellent. Change your ways. It's okay. And not everything works for everyone and every organization. But you always need to say, well, is this working for me? And go back to automation, because is automation right for everyone? Probably. Every automation is right for everyone? No. So let's not always remain looking at this thing, well, the robots as well, but look at the goal and then see if what you're doing serves this goal. Now, how do we get there? So first of all, why do we automate from, how do we get from automation to the goal itself? The first thing is that we talked about at the beginning, we do automate stuff in order to know things are working or not working earlier. In the manual era, when we did things like by hand, like building by hand and copying files by hand, and then waiting for 3 months of manual testing, only at the end we would know what to do. What is the state of the software? Is it ready for release? Is it ready to show people, show the customers? Is it ready for production? All the kinds of questions that we are interested in, we'd like to know the answer earlier. Otherwise, in the meantime, we might be wasting time working on something that is not important. We may not be in line with the market because we might continue in one way and the market might shift. So early feedback is something that's very important for us, for everyone. We do this automation, or every kind of automation that we're talking about, we do speed things up. The second thing is catching up. We think about automation or automated test as the goal in order to speed things up, but this is not the only automation. Like if you want to do exploration, for example, maybe you'll need to run a script that fills up the database with something. You were going to test something, you need users in the database, clients or customers registered in the database in order to just explore or play with the application. So in order to do that, you can run scripts, and then you can do the rest of the really important 10% in there. So catching up, or like making time for that, is very important, because if we're automating stuff, that means we have more time to do something else. Now, it's not like we're actually going to have really more time, but we are going to spend less time working on other stuff that is kind of a waste. 2 examples. So for the first thing I mentioned already, it's exploration. You want to explore how the application works in different ways, but if you already have like API tests and end-to-end tests that check that these kind of scenarios still work, that means that you have more time to explore other things that the automated tests don't tell you. The second thing is like more of a process thing. If you got unit tests by the developers working, that means there will be less stupid bugs to you to worry about. And you can spend your time more on testing like the real interesting stuff. So automation that not just only speeds up one thing, it also clears up time for other things as well. And like I mentioned, if we have a system that can collect information, we can make decisions based on these on the information that we get. And knowing when we're done, quality gates is a term that is used by continuous integration engines. Going to talk about them very soon. Basically, decisions when things in the process are done and we're ready to move to the next thing. And we're asking questions, well, are they done? Are they done to our quality? Are they done to our standards? Can we continue or not? And basically, machines can look at the information for us, and they can collect all kind of information that otherwise would be hard to collect. Now, if you look at the tools that we have and when we're automating stuff, that means that we can actually check if our process is working or not, because automation should reflect the way we work. It's not supposed to be conflicting with the way we want to work. Sometimes it does. Basically, if you're spending too much time on the tools themselves, and you know this from, for example, fixing automated tests, if the tests are kind of breaking all the time, our process doesn't fit where we want to go, although we have automation. So we can check whether our process is working, and is the automation really reflecting the way we want to work. We can check whether things are working, done to our way of thinking. We can check velocity. I'm going to show you an example of that. We want to see if automation actually speeds up delivery. Does it? So we can check that and actually do something about it. So automation is also about collecting the information, and maybe let us review that. So for example, this thing, I know it's kind of sacrilege, but I'm going to mention Jira here, because this information can be collected in Jira, which we don't consider any automation, but it is a kind of automation, because it collects information from all kinds and brings this to us, and we can do something about it. 90% of what we do is like live our lives inside Jira, which is not that good. But this is an example of something that is inside Jira and other tools as well. What you see as a cumulative flow diagram. If you haven't seen one before, this is one of the best things that Jira does, because I speak a lot of bad things about Jira. This is actually does well. You can actually see in every point of time what is the count of the tickets at any point. So one of the cool things that tools like Jira do is serve us information from history. Things that on the daily basis we don't have access to. Like if we ask people, remember what was the status of our, how many bugs were opened like last week? We don't need to remember that. Information is collected somewhere else, and it can be retrieved very quickly. What you see on the screen, by the way, if you see the green stuff as is for each point in time, is how many things are in development. The orange ones are in code review, and the purple ones are in test. So you can see that although there's a sort of the same number of things in development and in test, there's a growing number every time for things are collected to be code reviewed, which is kind of interesting, because if they are collected in code reviews, that means they're not passing into test. So it doesn't reflect our process, because our process goal is to speed things up and get as many things through the pipeline. So tools like that and automated data retrievals is all around us, and we can use that for our goal to speed things up. And if it doesn't, we can look at the information and do something with it. But enough about Jira. So let's talk about different ways we automate stuff. I'm gonna mention Jira at the end, I think, maybe, but most of it will not be about Jira. I am going to talk about different circles of cycles in the development that we are going through all the time, and which kind of automations we have around us that help us. And the things I'm going to start with is local development. So we're talking about the developer who's sitting on his machine, maybe at home, working remotely. It doesn't really matter, and they build software. So what kind of automation do we have there? Well, look at the IDE, the development tools. Development tools are like crawling with all kinds of shortcuts And I use a lot of shortcuts for doing refactoring, like renaming and extracting methods and variables, stuff like that. Running tests, building. If you're using something like Java or C# or whatever, it builds a software. You have a compiler that takes the text that you write on the screen and builds zeros and ones from it, which is kind of something that they did manually in the 60s. But also something that we like, we did compilers we take for granted, right? But copying files. I'm just preparing stuff for my next course, and if I have to copy a file every time after I build to a certain location, I would forget, and this will make my development part longer. I don't want that. So IDEs are not only just compilers and transpilers and interpreters, they also do things, automation around these things, so we can create stuff and make it shorter. Obviously, running unit tests. And I do separate the integrated tests that can be run locally before we move on to the next cycle, which is team development. So everything I can do on my machine, run things automatically, get the results, see what the operations are, it can be done right there on my machine. And a lot of it is automated. What can't be automated is what happens from this brain to this keyboard. Other than that, we can do a lot of things. And the next step, it's where things become a bit more interesting, because when we're the only one on the team, we're the entire team. We don't need to synchronize stuff. But that's not the way we work in a real organization. So I'm going to talk about the team level. It's kind of a team and org level. If you have questions, please write them in the Q&A box, but I'll get back to them at the end. The first thing is source control, and kind of people who are new to development, like people who are testing manually and come to this kind of source control makes sense to them, but they were not aware of everything that we're doing with source control. So obviously, if you need like files and stuff like that, you can keep them somewhere. But these kind of files need some kind of version. And basically, we have a source control version today with using a lot of Git and Bitbuckets and all kinds of Team Foundation server has its own source control. Basically, we need one source of truth. This is how the software really works. And despite of me working on one bit of code and you working on another, there's going to be one version at the end. And we need this version to be separated from the temporary versions of what I have and you have, and what we're going to build. So source control management systems basically do that. Do it remotely. It can be backed up. Backups, we have the ability to revert, and revert not just one file. We do different commits, can revert all of them. So we get the commit history, and we can build, and everything is done automatically by the source control. The second thing that we do in source control management systems allow our development in branches. Now, because I'm working not alone, and there are other developers on the team, other testers, doesn't really matter. We work in parallel. And how do we do that? So, like I said, the main developer basically sits on their machine. So everyone sits on their machine. They have their own version of the code. At some point, we need to do some kind of merging. And automation in these kind of systems let us do things basically with less errors. I won't say without errors, but we can do safe merging. For example, if I'm working on one feature and you're working on another feature, when I take your code, basically you haven't touched my code, so I can do this like blindly. I can trust the system that it will take and bring me every bit of code that you've written, and it doesn't clash with mine. If it does clash with mine, I'm going to be presented, well, what do you want to do with this and how are you going to merge it? So we can do safe merging blindly. We can do manual merging, but only on the bits that matter. And the systems helped us automate that. Obviously, we did more tests in order to run to see that merging did work. Like I took the right bits of code and it didn't break what I wrote. And if you're doing code reviews, I can talk about a lot about code reviews. A lot of systems today allow you to do pull requests in order to do code reviews. I really don't encourage that. Do code reviews when you're both on the machine. That's another talk completely. They look like they speed things up. They don't. Because remember, the goal is to have something out the door. Not speed up or speed up the developer right now by having somebody else review the code and thinking, I'm not going to bother them with what I found right now. It doesn't come up to quality repeatedly quickly. Okay, so we talked about source control and basically managing what I'm working on. But at the end, we actually want to get some software out the door. And the way we do it is we combine all kinds of automatic processes to have them master. And basically, it falls down to what we call a segment, a type of tools which are called continuous integration tools. These continuous integration tools are basically engines of automation. They do a lot of things. They do a lot of things well. And basically, the main purpose is, first of all, I want to avoid the works on my machine syndrome. I'm not going to build the software on my machine. You're not going to build the software on your machine because we might have different versions of Java, of compilers. I don't want to make the mistakes of building it once on my machine and then on yours. So we're going to have a separate neutral machine, someone from Switzerland. It will build the software as it should. And it's going to run the tests after it's built it as it should. And then going to run every test on it. It can do a lot of deployment. It can do a lot of checks before and after it deploys. For example, before it runs the test, it can check that the right version of Java is really installed there, or Spring. And if not, fail the build or whatever, and let us know what's working and what's not working. If it ran all the tests, it can tell us, well, all the tests are working. We can move on to the next decision to do. And we can do this in kinds of cycles and gates, and every tool calls itself differently, like pipelines and jobs in Jenkins, for example. So I'm talking about tools. Let's name names. The CI tool segment, basically, you have a lot of open source things, Jenkins and Circle CI. You have some open source, some not open source, TeamCity, Team Foundation Server, Microsoft. You have all kinds of things. What's really in common for them is that they do all kinds of things, and basically you can plug in a lot of things into them, so you can create your own custom automation stuff and tools into them. I do want to mention, though, why is it called continuous integration? And that goes a bit to history. So what was the original continuous integration? So if you think about it, continuous integration doesn't sound like a name of a tool. It isn't. Continuous integration sounds like a process. You continuously integrate stuff. And that's the name of the process. That's the original one. In order to do this, imagine that you don't have branches. You have one single branch, one main branch. And you continuously add code to there and merge it. In order for that to work in a team, you have to work in very small batches and write a lot of tests. So when you do this, you imagine that you're working today on something that takes a week to develop, and you don't visit the main branch for a week. Later, when you're going to commit, the code, you're going to have a lot of merges because the rest of your team were also working on other stuff this week. And this kind of integration will take a lot of time. So everybody will stop what they're working, merge together for 3 days, and we're 5 days before testing. The other option is continuous integration. Work on very small batches and integrate all the time. Run all the tests all the time. Not take a week, take 2 hours and merge again. Merging 2 hours of work takes a lot of time. Usually you won't get any conflict with anybody else while you're working on these 2 hours. So continuous integration is a process, and you can work with this kind of process with every tool that I mentioned out. The engine, it always runs the test. It'll always have something that runs the test and passes the test, and therefore you'll have something that is deployable, maybe even releasable at that point. So that's continuous integration, and usually that's a very good way to work in a team. Fortunately, not everyone works like that, but you'll mostly find, and again, supported by the tools themselves. Take your work to a local branch, spend 3 weeks there. Then when you come back, you have to pull everything from everybody else. It's going to be a big merge. It's going to be risky because the bigger the code base that you're trying to merge, even automated tools have bugs in them. So you'll need to run all your tests. You have to have a lot more tests because you need to make sure that you haven't broken anything for everybody in your team of 5 who took their own local branches for 3 weeks. So both processes are supported by the tools. The first one is better. Not going to talk about that too. I am going to talk about the tools themselves. Usually doing things is okay. Knowing what the results of the thing is much better. So yes, it can build my software and can test my software, but I want to see what's happening. And it's running on a different machine all the time, even without me knowing. So I want reports, and CI tools give you CI reports. What are the results of the build? Automatically, again, we commit something, it will run it will rebuild the software and run the tests. What is the build results? What are the test results? Coverage. I haven't mentioned coverage at all until this point, but a lot of the tools have plugins of other tools that can check different kinds of coverage and code quality and how complex it is, and give me reports so I can fix that very early in the process. We're talking about I'm committing, okay, in 2 hours I'll have a full report, not just on the build and test results, but the code quality itself, and I can do something about it. I can improve the code, I can refactor it, I can modify the code to be more modular, and knowing that I haven't broken anything. So CI reporting is very important because if it can send you a lot of emails, but if you don't look at the emails or go into the CI session, CI screen itself, you won't see what's happening. This is an example of a test result screen from Jenkins. It's actually from the Jenkins site. What you see here is the result of automation. Basically, what happened is that it built the software, it ran the tests. The test runner is not part of Jenkins. It's JUnit or Selenium in this case. It really doesn't matter. You can see that it ran on different kinds of machines. You have Linux and Windows and different types of browsers at the bottom. But it collected the information to one place. It's called a test result thing. Basically, it's called a JUnit report, but it's for another thing. And this information was ingested by Jenkins and then rendered to this screen. And this screen is something that everyone can go into and look at the results. So there's a whole lot of automation that you didn't need to do. It's done for you by Jenkins and obviously every CI tool out there. And you get all the information, all the tests, what's working, what's not working, each test with their own error in one place. All of this done automatically for you. So this is where we're going to talk about a bit about DevOps, because yeah, Data was the operations officer. So continuous integrations basically ends on the edge of deployment. So it built the software, it tested the software, and maybe created a package for it, but then we may be needing something more. Now, DevOps wasn't something that was always there as a role. Up until the early 2000s, we had something called system administrator, and they were looking at installations and installing new machines and stuff like that. And usually that was an operations thing, but we didn't call it operations. And they were their role involved like taking care of the production servers and other stuff as well. On the development side, we discovered that it may be not enough. Yes, we had our CI tools and we had to configure them, but then we had to do more script to support what we needed, create more virtual environment and stuff like that. So this is where the DevOps role really was created. It was kind of outsourced from these two grounds, the system administration on one end and the development on one hand, where people said, well, developers cost us a lot of money in more ways than one, but let's take this part of automating stuff for all kinds of development purposes. It already requires a lot of knowledge, different tools, different scripting mechanism, different types of debugging. So we need special people to do this for us. This is where DevOps and automation came from, really. So we kind of outsourced the infrastructure and automation of dev work to one role. And CI/CD became a thing. So CI, continuous integration, CD, continuous deployment, our ability to not just integrate and build software, but automatically deploy it to somewhere. Where is this somewhere? So continuous delivery, we're thinking production, but it doesn't have to be just production. We already know that we have different stages where we want to test stuff. So for example, our CI server builds and tests the software. Does it do it in isolation? Not always. We may have our software built, run on the CI server, but it talks to a joint database where every tester runs their own, because we have one license of database. So we're talking about different environment, and these are the stages, really. We're talking about staging. We're talking about stages in the process, where every environment can tell us something about this. Here's an example. Suppose that you're building a new feature. The first thing that you want to do is check that it's working. So you need an environment to doing that. But it doesn't have to be like environment that looks similar to the production. Just want to see that still functionally the regression tests are still working, and the new functional tests are working. And you don't need to do this without being logged into the system. So these kind of things, we kind of separate environments so we can learn things from them. If the functional stuff works, then we can move on to the other stuff and check if it's working on a full near production stuff. Same thing, you can do it functional stuff as well. So you can do API tests, but if they're working, then we can check the end-to-end tests. We can talk about different stages where environments are set. Some kind of things are deployed, types of libraries, setup, data, parts of the software, and we can learn each from them, and then we can decide, well, if this is working, we can move on to the next. All this obviously done manual, and that does not occur manually. If it was manual to do that, it would take a lot of time, and again, it wouldn't be repeatable. I'm sure you've heard of Docker containers. Docker containers are like the new technology that allows us to create repeatedly different environments for running stuff. And you have things like Kubernetes and stuff like that to manage these kind of environments. Here, for example, you see a screen, again, in Jenkins, about deploying stuff in different sites and running tests. What you see on these kind of things, on the horizontal things, are what we call pipelines at the same point. And on the vertical things are stages in the pipeline. So we can, again, we see in one place what happens in different things using the both superpowers of Jenkins and other CI tools as well. To do these things, the first one is the automation, engine automation, to run different things. And the second is to ingest the results from what happened. And the third part is to take decisions whether to continue or not. And we can review everything in one place, again, automatically. Let's talk about testing, because testing is very important, right? So basically, like I said, we're trying to set up environments to what we want. Our testing environment, it could, well, let me say that again. What we want and what we can, okay? Sometimes it's not possible to change everything today. I was working with teams that for a very long while had development plus testing environment, and the developers and the testers would step on each other's all the time because they had one single database that they would never clean up, and they update the data there. And this was the constraint. This is how they were living. And sometimes you have to do that, but we'd like to have the ability to create different environments for that. So like I said, the testing environment could be like just the new functionality or the old functionality, working with that. But then we move on to different stages with more complex environments, which kind of simulate what happens at the production level. You can have like a load balancer or gateways and stuff like that. And you can collect metrics along the way. You can run different integrated tests. You can run with simulators. So for example, or if you're running, if you have mobile software, you run with emulators before it hits the hardware, because you have environments that work against each other in something that can be automated. You can have simulators, actual simulator, if you don't have things ready yet. I worked on long ago on software that was working with real hardware, and it took a while until the hardware was actually built. We had to work with simulators and rerun tests automatically with the simulators. Obviously, end-to-end tests, regarded, we need to discuss what end-to-end actually means. And then you can run things not only in pre-production, you can run tests in productions. And there you actually use mechanisms like feature toggles to expose some kind of functionality to some kind of audience, and you can regulate that, and you can maybe revert versions, maybe you can republish versions all automatically if you find something that's not working or not working well. And you collect stuff automatically all the time, and you ingest it and you can look at it. A bit more about reports. So basically, reports is data that we collect. What we can infer from that is up to us. So we can do a lot of things that these kind of tools help us do. Define and confirm doneness. Is it doing what it needs to do? Functionally, not functionally, performance-wise, other contexts as well. Is it ready to be released? Is it done? Really done. How much of a coverage and what kind of coverage do we have? Like, is code coverage enough? Well, here's a tip. No, code coverage is not enough. Code coverage basically checks if you run this line of code at least once. Now, if you haven't, it's a good hint. Maybe you should write a test for that. But there's a lot of questions you can ask about that as well. API coverage. Are the right and important APIs covered by tests? Features, same way. We can get this kind of information, look at it, and decide what to do. Returning bugs. This is something that needs a bit more work, but are bugs returning to the same bit of code. These are kind of returning bugs. So I'm not counting like the same bug returning. You would notice that. But bugs are returning to one bit of code over and over again, different bugs. You can get that from these kind of tools automatically if you put a little bit of effort into them. Complexity, again, you can identify different patches of code that are complex. You can, with some tools, see what kind of duplications you have in different types of the code. You can do a lot of refactoring to that. Escaping bugs is something that we usually don't think about as can be automated because they're not. Escaping bugs are basically things that we didn't test for, didn't check, they came out from the actual users in production. But, so this cannot really be automated, but the process of fixing them and making sure that they don't repeat can be automated based on the feedback that we get, writing tests, and again, feeding that back into the system. So, there was a lot of automations. Does it all work? Most of the time. Well, first of all, you need some kind of mental thing that it's not going to be a one shot that you're investing and then you won't invest anything in automation ever again, because that doesn't work. You need a lot of time. You need a lot of learning tools and how they fit your process and how to automate things in order to make sure that it fits your process. If you're doing it after you started development, 5 years after you start the development, there's going to be some catch up, because you may, if you're introducing automation now, that means you have like 5 years of no working automated tests. If you try to start automating the tests now, it's going to be very hurting, very painful. But sometimes like teams just put other teams along the side to catch up with automation. Even following sprints, like if you have spilling sprints from development and then tests are not ready at the end of the sprint, then you try to write automated tests after that, all kinds of automation. Well, first of all, you need to decide what your done actually means, but then you'll need, if you don't do this as part of the work, it will just continue to spill over and you'll chase yourself. So you need to think about automation as something that's going to evolve over time. A lot of these tools can be set up at one time. It doesn't take too much to set them up and configure them for what you have. Most of the things that you have, just plug in. But the mindset of looking at things, looking at the results, changing your way of work based on what you see is something that's going to take work. You need to evolve the automation. You need to write more or less or different scripts as you go, because your needs change over time, because the product needs change over time. I do want to warn you, though, that there's a lot of, we're thinking about, we're going to speed things up. Are we speeding things up the right way? So, for example, I don't know, the developer kind of set up all the keyboard shortcuts they can in order to speed typing up. As that's cool, but if testing still takes like three weeks in end to end of manual work, speeding the typing doesn't really work. So you need to, and plus it probably can create, if you're creating automation scripts, can create more complex things to manage, and it kind of swoops the patterns of work with it. Like, this is how we work, and therefore we have to engage in fixing fragile tests because we are not willing to check what's wrong with the code rather than fix the tests. So we need to think as automation as really as part of the work, but we want to finish, but going back to where we want to be. And C3PO and R2D2 really are where we want to be in a galaxy far, far away. We want the ability to have quality releases over and over again, repeatedly, and done quickly. And if our processes and our tools and our practices don't take us there, we need to change it. So everything we do in terms of automation and other stuff as well, we need to look at it in this kind of goal. Will it help us? Maybe it will not help us immediately, but if it will not take us there, if we're on the road, we're thinking we get there, and it doesn't take us there, we need to do something new. And basically, this is what I wanted to share with you today. So first of all, thank you for listening in and waiting patiently to see more robots. If you have questions, please write them in the Q&A box. I will start answering them immediately. Let's see what are the questions. The most popular question, where can we find the recording of this session? Well, there is going to be, we are already recording this. It's going to be published in the next couple of weeks on everydayunitesting.com or testingguild.com. So yeah, any recommendation on how to incorporate AI in the automation process? Oh, that's a good question. Very, very patiently and by checking everything you believe about AI. AI is basically a way, an automated way. Does it work? You need to test for that. Does it work always? No. So there are all kinds of things like tools that check patterns of like end-to-end testing. We have tools like Apply tools that do like UI based on AI patterns and so on. It's, again, does it help you to get to a quality product repeatedly and quickly? If it does, yeah, go for it. You need to check if it's right for you. If it doesn't, maybe find another tool. Maybe if that doesn't work, build your own tools. I'm really skeptical about the AI thing. So far, I don't see us losing our jobs very soon. So, next question. Is it okay that I don't have the option to enable audio video? Yes. This is a webinar. Usually you don't, only the panelists have a way to do that. How do you handle long running tests? I wait. Okay, so let's start with why are the running long? Some things do take a lot of time. But first of all, are our tests really checking for these things? Let's say you have 100 end-to-end tests. Each one of them starts with logging into the system, which takes like, I don't know, a second. Do you need to run everything with login? Or maybe you'll have like 95 tests running as a logged in user. What you want to test is what you're interested in learning. Things may take a long time, but they can maybe be replaced with other shorter stuff. They can be separated from the short running stuff. Like if you have like unit tests running with end-to-end tests in one suite, maybe you probably should separate them into two different suites that runs separately. First, you run the unit test and the short running tests. If they succeeded, then you can move on to the next one. So if you have things that you don't get early feedback on, you should think about what can you get and learn quickly and what you can't, and you have to wait for that. Sometimes it doesn't make sense to release until you have everything running, makes sense. But different stages, you might want to learn how they're working earlier. So splitting into different suites, running in different contexts, defining what you want to learn from this kind of run, and then maybe switching different kind of things. Something very something that you can do that will save you a lot of time. If you have an end-to-end web thing that you have to navigate between pages and do kind of navigation, of running through different screens, it will take this long, okay? But if you're doing, if you're replacing that with something that's similar with APIs, it will take this long. Does it replace it completely? No, but this augmented with other shorter tests, like unit tests or something like that, can give you enough confidence that this thing is working correctly. So it's not like you go head on into this is what I need to automate, but if it doesn't give you the answer that you need quickly, then maybe other ways will give you the answer that you're seeking. I feel like a very wise man right now. Next question. How did I, regarding the long-running test, this time with the completion, concluding team builds a database. One set of tests we need to run ensuring data is actually saved on disk. To this, we need to physically pull our machines and verify the expected data is actually there. Yeah, some things you can't speed up, but maybe you don't need to run a whole set of these kind of cases with this. Maybe other cases can be replaced with shorter tests. Maybe you can run things on a simulator to find out if at least some of the structure is working, and then if that's working, you can move on to the rest. So any hardware related things will slow you down, obviously. But even then you can find things that you may be able to tweak to get answers a bit early. So separate processes, running in parallel. Well, the question is, do you pull these as separate processes, which can take days, even weeks to run, have them integrate to the tooling, or just keep them separate? Okay. The guidance would be, which I haven't mentioned here, but somehow fits there. You want all the information in one place. That means regardless of how you run it, you want to ingest it into one place, which is basically today, that place would be the CI server, the continuous integration server, because this is where all the results are going into. You can have different reports, but then you have to look for them in different places. So that's the main guidance. How you get there depends on how you want, how you think you'll be able to optimize the run itself. So maybe you can run differently, but you want to ingest all the results to one place. So you have to, you have to think about it strategically. You have to think about what you need and what your constraints are, what you can run and what you can replace and what you can automate, what you can run in parallel. And I'm not saying don't run things in parallel, because sometimes it does make sense. But if you don't run them in isolation, the result that you will get might be confusing, not repeatable, and will take you more time to find out what the problems are, even if you run them sequentially. So it is a strategic thing. Thinking about how to run things and get the results that you want is a strategic thing. It needs mindfulness. It needs a lot of thinking about, a lot of understanding of how code runs, how code intersects, how databases are. If you're a single database, if you have multiple databases, what kind of things that you need to spread around, what you need to collect. It's not simple what we do, really. So yeah, so there's no one answer, but the answer is think about it. Which coding language do you suggest for beginners in automation QA? Python. It's very easy to learn. The thing is that, and I hope I won't ruin it, it's not about language. What I find the most problematic is for people going into automation, especially for manual testers, is that they are becoming developers. So learning development language doesn't make you a developer. Making a lot of mistakes writing software makes you a developer. So language is basically easy to learn. It's not language, by the way. It's language plus tooling plus libraries. And if I tell you go learn Python, and you don't, and I will forget to tell you that, yeah, you have a lot of libraries that you need to actually learn about, those that call APIs, and those that deal with mathematics and stuff like that. Then you may learn the language, but it won't be useful for you when you go to automate stuff. So it's always like learning a bunch of stuff. It's never the language. It's just you pick a language, learn it, start working, and see what you need to learn otherwise. The other thing is, I always tell you, don't do Python if everybody around you is doing C#. Because even if it's an easier language, you won't get help from other people who don't know Python. So it's even an environmental thing. Last question for today. How to determine the right degree of automation at any given moment? Maybe you recommend to automate as much as it's technically possible. No, think about what you want to learn. Again, this is a local optimization. We're going to automate everything because this will make us go faster. No, you will waste time on automating the wrong things. So you need to take a step back, think of what's interesting you at this point, not like automate everything that you've written, like you haven't touched code in 3 years. It works in production. You don't need to automate it because it still works and you're not touching it. So think about what's interesting for you to learn and then automate that stuff. I'm going to say goodbye now. So thanks again for coming today. Glad to have you visit me. Watch this space and social media for notifications of when the recording will be up. Second, where the next webinar and what it will be about, I don't know yet. But follow up. If you have any questions, let me know. If you need help in consulting, training about this stuff, about all this other stuff I mentioned, let me know as well. I hope I can help you. And with that, I say thank you. Have a good morning, evening, wherever you are. Hey everyone, if you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.